How can you use similar triangles to determine rate of change of a proportional line and write an equation? There's a lot to unpack in this. This is probably the most difficult whiteboard I have here. So here we go. Similar triangles are triangles that have the same angles but not necessarily the same side lengths. Rate of change is your slope. We're going to talk about that a little bit more in detail. Rate of change of a line. A proportional line is a line that basically it is a straight line that starts at the origin at 0, 0 and just kind of goes through the origin and kind of increases like that. Yeah, we'll see some examples of that. We talked about that more in the last video. And an equation, I'm going to write some of those. So let's kind of just get into practice here. All right. So we have this line AC, right? ROC is your rate of change or your slope. And I have these two triangles that are actually congruent. So they're similar, but they're also congruent because all the side lengths are the same. So if I were to say here, what's the rate of change of line segment from A to B? Well, that's going to be your rise over your run. And that's what the point of these triangles is. So it goes up from A to B, it rises 28. And the run is 28, which equals 1. So your rate of change is 1. For every 1 unit, it goes up 1, over 1, up 1, over 1. And that's your rate of change. Down here, your rate of change of B to C is rise is 28. And your run is 28. You could also say this is like your change in your y coordinates from B to C. How far up does it go? How far over? You could draw these triangles on the other side and they would be equal, like 28, 28. It'd be the same triangle on the other side of the line. So 28 over 28 equals 1. These, the rate of change for both triangles that are similar should always be the same. It should always be the same. And it is, 1 and 1. Which means you could have just done one of them to find the rate of change for the whole line. So from A to C, it means your rate of change will be 1. And to write an equation, you would say that your y coordinate is going to equal 1 times your x coordinate, which is 1x. And you could also say y equals x in this situation. One way we like to think about this mathematically is we can say y equals mx, where m represents the slope of the line. And the slope is the same as the rate of change in a proportional relationship. They're equivalent. So y equals mx. Now, here's another example. In this case, we have different triangles. They are similar still. All their angles are the same, but we have different side lengths. So when we go from A to B, our rise is 21, and our run is 28. This can get reduced to 3/4. So our rate of change is 3/4, which in a proportional relationship is the same as our slope. So our slope is 3/4. Rate of change from B to C. Our increase in y coordinate is 30. So our the change in y is 30 over the change in x is 40. 30 over 40 equals 3/4. So these are identical, which they should be. And the slope is going to be 3/4 as well. So when we say y equals mx, y equals 3/4 times x. The equation would be y equals 3/4. So whatever my x coordinate is, I multiply it by 3/4 and I'll get a y coordinate. And then I can plot that point and it will be somewhere on this line. So y equals 3/4 x. Hopefully this is seeming a little bit simpler now, not as complicated as that big question at the beginning. I wanted to give you an example where I drew the triangles on the other side of the line. In this case, we have, I think sometimes when you draw them above the line, it's a little bit easier because your rise is first, then your run. Rise, run. So to me, above the line is a bit easier. So for the smaller triangle down here, my rise is 4, my run is 5. So it's 4 over 5. For the bigger triangle, my rise is 8, my run is 10. 8 over 10. This can be reduced to 4/5. They are, so these are equivalent. And now I can write the equation that y equals 4/5 x. You take your rate of change, you multiply it by x, and set it equal to y. That's how you write your equation. Now, there's a couple other scenarios we're going to have here. One would be where you have an equation and you have to graph it. Y equals 2/3 x. The first thing you do is what happens when x is 0? Well, when x is 0, 0 times 2/3 is 0, so we can put a coordinate right there, 0, 0. Then you just need to do one more, and you can get the next coordinate by going up 2 and over 3. Up 2 over 3. Plot my coordinate there, and I can draw a line. This should also go through 1, 2, 3. This would also go up 2 and over 3 more, which I didn't draw on there, so it'd be about right there. Perfect. So again, you can continue to go up 2 over 3, up 2 over 3. You can do it backwards and go down 2, or back 3 and down, back 2, down 3. You can reverse it to go both directions. That's how you would graph the line. You would only need 2 points and then draw a straight line through it to graph it. Just because the line, if he goes through 2 points, everything on there is going to be on that line. It'll be fine. You just need 2 points to graph a line. A straight line that goes through these 2 points will go through every other appropriate point on the equation. Now, there's also a different scenario. Say I have this line graphed and I want to make sure I'm comparing slopes. So if I have a line like this purple line up here that has a steeper slope, that means that this equation is going to be y equals, and this number is going to be greater than 2/3. So in this case, this value is greater than 2/3 x. And if I were to draw a line that had a smaller slope, it would be y equals, and it would be less than 2/3 x. So if you're trying to guess what these values are, you could say, okay, this one could be y equals, instead of something greater than 2/3, would be, say, 3/3 x. And this one, something less than 2/3, could be 1/3 x. So those could be guesses as to what the slopes of those lines might be when guessing. So just wanted to give you that just in terms of estimating slopes and how can you use similar triangles to determine rate of change of a proportional line and write an equation, plus a little bit of graphing here too.